Hello, welcome to Water In, Water Out, Best Practices for Dental Water Treatment and Processing in the Offices. My name is Leanne Kiefer. I'm Director of Clinical Services and Education for Crosstex, who's sponsoring tonight's program. I'm very pleased and honored to see so many of our loyal viewers joining us for tonight's webinar, which is going to be very exciting. We're going to be talking about an ever-present solution, that being water. And while the composition is a very simple structure of chemical hydrogen and oxygen, it has a power to be a life force, literally. And in dentistry, we can't get away from water. But tonight, we're going to take a little bit of a different turn or a different spin on water. Rather than talking about dental unit water lines, we're going to be talking about the quality of the water and how it impacts your practice, the care and safety of your patients, the investment that you've made in your equipment, and what the options are. We are so honored to have two learned speakers on water quality to join us for this evening. First, I'd like to welcome Matt Chandler, who is our Senior Product Manager for the Vista Water Purification and Processing portfolio. And Matt's viewpoint on water is that it is essential. It's essential to not only dental units, but to life itself, to corporations, and to the facilities that we work in. We're also going to be joined at the end by Jim Chandler, who brings 40 years of expertise in water technology, and he was the founder and president of the Vista Research Group, which was recently acquired by Crosstex. And so at this point, I would like to invite Matt to begin telling you about the untold story of water as it relates to dentistry. Welcome, Matt.
Well, thank you so much, Leanne. I'm honored to be here with you all today. So thank you for that nice introduction. And also thank you to all of you who have joined us today to hopefully learn a little bit more about how we use the water coming into the practice, how it's used in various work processes within the practice, and also importantly, how water leaves the practice and all the different things that we really ought to consider in terms of how we use water. So let's first start with the why. Why are we here for the next hour or so talking about water, Leanne? And that's because water quality really does affect nearly every function of dental offices. As you alluded to already, poor water quality can actually even damage dental equipment and instruments. And yes, dental unit waterline maintenance has rightly received a lot more attention in the last few years than it has in many years past. And we'll certainly touch on that today. But I also want to take a little bit broader view, as you let us know in the introduction, to talk more broadly at a higher level about how to think about the water as it comes into the practice and how we use it in really every aspect of practicing dentistry.
So the water that's coming in through the plumbing into the main part of the facility and not so much focusing on that 8 feet of 2mm tubing that's in the dental units.
Yeah, that's right. We really need to take a holistic view of water, you know, really starting in that mechanical room. How is the water coming in? What are we doing there, if anything? How are we using water in the Steri Center? You know, water is
huge,
crucial,
very important, absolutely,
to sterilization and instrument reprocessing, and then of course also in the operatory environment. So we really want to touch on all of those things today. And as I mentioned, certainly dental unit waterline maintenance is absolutely critical for patients and staff, and we will touch on that. But we have many other resources, as I know. You know, you and others have given us very deep dives on that topic. So in some ways, I'll just refer to some of those more technical resources for those sorts of things. But we will certainly talk about some best practices as they relate to dental unit water lines. Because beyond this, as I mentioned, water quality really does affect virtually everything else in the practice. Your equipment, your work processes, and ultimately even your profitability as a practice. So the goals that we have today are first to understand some of the very basics as it relates to water quality concerns and some solutions to those concerns, to learn how we can protect dental equipment and instruments, because those are obviously very significant investments for the practice, and then finally we want to discover how we can use water and certain types of water systems to make staff more efficient and productive, and also to make our care as efficacious as it can be.
And I think, Matt, sometimes in dentistry, we tend to get into patterns, habits, and maybe some of the things that we've been doing for a long time, you know, they may not necessarily be wrong, quote unquote, but there may be a better way to do it for the longevity of, like you said, the equipment and the practice.
That's right. That's right. So as we move forward here over the next few slides today, I'm going to cover at a fairly high level just some basic terminology that I just want to make sure we're all on the same page about certain things. Some water conditioning and pre-treatment concerns that we should just be aware of, and then we're going to really dive in and take a deeper dive into all those various areas of the practice.
Sounds like we're doing Chemistry 101, Matt.
There'll be a little bit of that, but I'll try to keep it, you know, pretty high level and not get too technical. You know, one thing that's interesting to understand is the nature of water as it exists in our environment. So this is commonly referred to as the hydrologic cycle in geology or in scientific circles. And what this describes is this natural process of how water is recycled throughout the environment. So as this little diagram shows you on the right-hand side of the screen here, we have evaporation from surface water, we have condensation and precipitation, and the water comes back to Earth, where runs off into surface water or into groundwater. Wells, water treatment plants, all affect the quality of water, and that's because water is almost never just purely H2O as we encounter it in nature. That's because water is actually a solvent, which means it wants to dissolve and absorb substances that comes into contact with. So this can happen naturally in terms of what the water absorbs in the ground, and also it can happen in terms of man-made intervention and how water quality is affected by municipal treatment processes.
I think I've heard you refer to it, Matt, as the universal solvent.
That's right, yes. In chemistry circles, water is known as the universal solvent because of that, its property to want to dissolve that which it comes into contact with.
Well, I think it's another unique quality of water. I mean, we've said that we use it in every aspect of dentistry, but when we think about it in the form of matter that it comes in, it meets all of the liquid, the solid, and the gas as far as an element.
Yeah, that's right. The other thing that's interesting about the hydrologic cycle, Leanne, is that water quality can actually vary considerably by geography. So because of local geological features, even treated municipal water that's delivered by the city can have a very different profile in the Boston metro area as it does in Santa Fe, New Mexico, for instance. And that's because the geology is so different. So that's just an interesting thing to note, but also be important as we consider certain water quality concerns, as specifically in the Sterry Center, which is something that we'll get into in just a few slides.
Well, I know that living in Colorado, I have colleagues that are talking about the challenges that they have with hard water, and in particular when they're rinsing instruments from the tap water after they've been cleaned. They're seeing some residual elements, and I think that's sort of what you're referring to. Yeah,
that's certainly one component. Water hardness can affect a lot of things, including the longevity of equipment and even mineral deposits that can be left on instruments. That's something that we'll get into in a little bit more detail here in a few slides. So a couple of terms here, and this is going to be about as jargony as I'll get in this presentation, but it's important to be able to distinguish between what's known in the water chemistry world as suspended solids and dissolved solids in water. So suspended solids are that free floating particulate. So that can be, larger particulate, like in some cases where you have sediment, sand, silt in the water that needs to be removed, but then also dissolved solids. And there's an analogy that I like to use to help distinguish between these, and that's the analogy of sand and sugar. So imagine, if you will, for a moment that you have two buckets of absolutely pure water, H2O in each bucket, and you've got a handful of sand in one hand and a handful of sugar in the other, and you throw into each of those two buckets. Okay? You can stir up that water, Leanne, and now imagine you've got two giant paper coffee filters, and we're going to pour the water from each bucket through each of those coffee filters. What do you think would happen, Leanne, as we do that?
Well, if I go back to my chemistry class, because of the sugar, it's going to be dissolved, you won't have anything left over, but when you would put the sand through, that particulate matter is going to be strained out, so to speak. But
yeah, that's it.
It won't be in solution.
That's exactly right, Leanne. You got the gist of it. And in this analogy, that paper coffee filter is an example of a very basic form of physical filtration that can remove some of those suspended solids. So the filter is going to catch the sand, not catch the sugar. That's really the difference between a contaminant in the water that is a free-floating suspended solid or a dissolved solid. And when I say contaminant here, I don't necessarily mean microbiological contamination, but just stuff that's in the water.
Something other than waterborne bacteria.
Yeah, that's right. And bacteria can actually be included in the contaminants that I'm describing, but it's not exclusive to that. So I'm just talking about stuff in the water that we need to be concerned with as we move forward. So real quickly, municipal water. This is the water that comes from your city. It's pre-treated and it's provided to the vast majority of dental practices in the U.S. in particular.
So it's what's coming into our building.
That's right. That's right. This is water that would not come from a private well, but would come from the city. And that's important to draw that distinction because water that comes from a public municipality is regulated by what's known as the Safe Drinking Water Act. I'll refer to that sometimes in shorthand as the SDWA. This is legislation from the EPA that dictates maximum contaminant levels, is what they're known as. And these are for contaminants that could pose health risks potentially. This same
like what, Matt?
Oh, like
example?
Lead might be an example of something that could be a public health risk, and that is regulated again here by the Safe Drinking Water Act. Now, the same legislation also has secondary guidelines that don't address contaminants that would be of public health concern, but they're really more aesthetic in nature. So odor, color, taste, those types of concerns. So these aren't really regulated to this extent that the municipality has to control those to a certain level, but there are guidelines associated with this legislation.
Almost like standards.
Yeah, that's right. That's right. And the primary standards are what's critical and what has to be met by the local municipality. And this is important because whenever possible, it's much better for the practice to get their source water from a municipality, from the local city water department, because of those regulations that are in place. What's our alternative? If for some reason, and this is a small percentage of practices in the United States, but there may not be the ability to get that water from the city, and in some cases a private well is the only option. It's not ideal for input source water when it can be avoided, and that's because well water is highly variable. And that's due to what I mentioned earlier about just differences in regional geography, or regional geology, excuse me, and also just environmental concerns that may surround the well. You can have runoff from snow or from a farm or whatever there it may be. Well water also typically has a high level of dissolved solids, which is something that we do need to be especially concerned about in Steri Center, which we'll talk about in a moment. It tends to be water that is harder, has higher levels of water hardness, and generally a higher level of microbiological contamination as well that needs to be contended with. So if a practice is on a private well, very often there's a level of pre-treatment that's required. This includes sometimes water softening system, and chlorine disinfection as well because of that microbiological contamination that I mentioned.
And just to clarify, Matt, with that statement, again, you're talking about, when you say water softening, you're talking about all the water that's coming into the building. You're not just talking about water that's going in specifically to a dental unit.
That's right, Leanne. Very often it can be beneficial for a practice to soften all of the water that they're using in the practice, not just in the operatory environment, because as we'll see in a moment here, we'll see that hard water can actually accumulate, scale inside pipes, appliances, equipment, and it can greatly shorten the life of pipes and appliances. So that's a consideration, especially for practices in areas that have very hard water. So now on this slide you see a picture of what would be a very typical sediment filter. This is typically known as a sediment filter. This is about that physical filtration. This is essentially our paper coffee filter, to go back to my earlier analogy. This is again, designed to remove suspended solids from water. This is not going to be removing those dissolved solids that we talked about.
So this is for the sand.
Yeah, and debris.
Right.
This is very often installed alongside a solenoid valve, maybe in the equipment room, where you have the water main coming in. So this would just be a very first step in removing some of the stuff that can still be present in city water, and making the subsequent treatment more effective, and also a way to help protect equipment after this filter.
So we're sort of talking about the bigger pieces, so
That's
to
right.
speak.
That's right. And the bigger pieces here might still be very small.
They still be microns, correct?
Yeah, we're talking at a micron level. Very often a filter like this might be a 50 micron filter.
Wow.
So that's still very small. In the grand scheme of things, we're removing a lot of the junk that may be introduced to the water lines by, let's say, frequent construction in the area.
That has an impact?
It absolutely can. If frequent construction surrounds the practice, there's that many more opportunities for sediment, dirt, debris to be introduced into the water mains. So it's not coming from the municipal treatment plant, but it can be introduced on its way to the practice.
So it seeps in.
Essentially, it can not seep in the sense that it comes through the pipes usually, but as in areas of frequent construction, they're frequently having to tap into those water mains, and that's as sediment can be introduced, which can, if it's not filtered out appropriately, that can end up all the way into your delivery system if you're connected to a municipal source.
You don't want that in a sterilizer or in a handpiece.
No, you absolutely don't. So this is a relatively simple, inexpensive way as a first step for filtration on a water main that's coming into a building to take care of some of that easier stuff. This is relatively common in newer offices in particular, to have some sort of basic sediment filter in place on the water main, but it's not always present in older buildings, even though it's relatively easy to be retrofit if you needed to do that. We highly recommend some sort of basic physical filtration on the inbound water line. Again, as I mentioned, especially in areas where there's heavy or frequent construction, because that can help to protect everything that follows.
Matt, we've talked about, maintenance of water lines or dental unit water lines, but I would think this filter is paper before. That also has to be maintained and changed on a routine or a scheduled basis.
Yeah, that's right. That's a good point, Leanne, because as this filter becomes clogged with the debris that it is designed to, remove, it can actually steal water pressure from the entire building. And sometimes noticing a change in the water pressure that's delivered, maybe not only to a delivery system, but even to the sink in the restroom, that might indicate that this sediment filter is clogged and just needs to be replaced. So depending upon your area, the prevalence of construction around the practice or lack thereof, a filter like this could last a year or two, or it could last a month or two. It just depends on how quickly that filter fills up.
So again, IFUs are important for this as well, the instructions for use.
And also just paying attention, to an observation of a potential loss in water pressure. I mentioned water softening before. The picture on this slide is just an example of a very typical water softening system that you might even find in a home or a small business. And in very large buildings, you might see a bit of a different type of system, but they all operate similarly, Leanne. And the way water softening systems work at a very high level is essentially an ion exchange process. So hardness in the water typically comes from dissolved calcium and magnesium in the water. That's what creates hardness and can lead to a buildup of scale. Now, what a softening system like this does is exchange salt for those calcium and magnesium dissolved solids in the water.
Like through a membrane of sorts, or just an exchange?
It's actually a special, there are beads inside this softener, and a softening system will regenerate itself, and that's why if you have a softening system, you ever wonder why you have to pour salt in? Yeah, that's exactly right. So during a regeneration cycle, the softener can sort of refresh those beads with the sodium ions that it will then exchange for the calcium and magnesium. That's right. And that greatly reduces any concerns about scale or buildup in the pipes and in the equipment. As I mentioned, that it's those mineral deposits that we need to be concerned about, that buildup of scale, because it can actually damage and shorten the life of equipment. And also, think just beyond an individual appliance in the building, but even the pipes, the plumbing that you have in your building can become clogged with this scale.
It's almost like biofilm does in the dental unit water lines, scale can do in the plumbing lines.
Yeah, that's not a bad analogy. Yeah, and that scale, as it builds up inside those pipes, will also reduce the water pressure that you're able to deliver.
And we need to remember that the water pressure through our lines and our equipment, it's not pressurized until it does reach our dynamic instruments. And so if we have a low flow that's being caused by that physical problem, it's going to impact our efficiency to be able to practice.
That's right. And we'll also see that water pressure is a big factor in on-site purification. If you're using any type of water purification system on site, which can be beneficial for lots of reasons, water pressure is one of those variables that can make your on-site purification either more efficient or less efficient. So in general, water hardness is measured in a couple of different ways. You might hear it referred to as grains per gallon. That's a measure of hardness, but it has an equivalency. That's about 86 part per million or milligrams per liter of hardness. And that's about the threshold which we would say if you have water that's harder than that, harder than 5 grains per gallon, you're likely going to see real benefits to installing some type of softening system in the building.
So Matt, how would I know? I mean, like I said, I live in Colorado. I'm guessing our calcium and magnesium might be kind of high. How do I know what it is coming into the building?
Oh, that's a good question. Sometimes you can get a report even from your local city water department that will tell you kind of an average profile of the water that they're delivering. Sometimes that will include hardness. But if you're not able to get that for any reason from your local municipality, a local purveyor of water treatment equipment, like that would sell softening systems and iron filters and that sort of thing, usually will come and do just a very basic water profile test, very often for free, just to tell you kind of what's in the water so you have an idea about what you're dealing with from a water chemistry or a water profile standpoint. Again, that's not necessarily a microbiological test. No. That's just giving you metrics for what's in your water that would include hardness, would include a measure of dissolved solids in some cases, iron levels, that sort of thing. So you're not always going to be able to get all of those things from a city report, but a basic water profile test would give you all of that and more. So we've talked now for a few minutes about pre-treatment and pre-filtration. Is that necessary? Well, for many practices, the answer might be no. If you're on a city water input source and your water isn't too hard, you may not need any more pre-treatment. Even that said, some sort of basic, relatively inexpensive physical filtration like that sediment filter that I showed you earlier can really be beneficial. If you do have issues like hardness, or maybe you are on a private well, you may have issues of microbiological contamination that would need to be contended with. Those are typically best addressed by a local purveyor of water treatment equipment or products. That's because those companies are going to be most familiar with the solutions that work best in your area. As I mentioned, the water, in one part of the country might be very different from a water profile in another part of the country. And so some combination of something like, well, if you're on a well and you need a chlorine tank, or you've got very hard water and you need a softening system, or maybe very high levels of iron, you need an iron filtration system. They're going to be very comfortable and knowledgeable about dealing with your local water profile. Okay, now we want to move into one of the key areas of the dental practice, and that's the Steri-Center for instrument reprocessing. That total dissolved solids that we talked about earlier, that's a big deal, because even using treated city water, it's not good enough for use in steam sterilization. And that's because of this issue of dissolved solids. So we want that level of dissolved solids, specifically as it's used in a steam sterilizer, to be zero, or essentially zero. And that's just due to the nature of how these steam sterilizers work. They turn that water into steam. The steam is what does the sterilizing of the instruments. And due to what happens when water changes state from liquid to gas, it will leave behind anything that is dissolved in the water. And what you don't want to do is leave behind those dissolved minerals inside your sterilizer.
The leftovers.
That's right, because over time that's actually going to damage your sterilizer. Now, some units, I would use one example here, might be like Sycan's Statim. That's a sterilizer that uses fresh water with each cycle. That will actually give you a warning and say if you have higher than 5 parts per million total dissolved solids, it will actually give you an error and say poor water quality and won't allow you to run that cycle until you've put a higher purity grade of water in the machine. Now, other types of sterilizers won't necessarily give you that warning. Their instructions for use might say use distilled water, but you could actually put pond water in some of these things, Leanne, and it will do its best. It will run, and over time you're going to end up damaging that unit because of the dissolved solids that are in the water.
Well, and I would imagine, Matt, that with the units that don't have that pre-warning signal, that can't recognize the quality of water, the importance of following the preventive and routine maintenance to eliminate the residuals that are hanging around in the chamber is going to be critical to the life cycle of that unit.
Yeah, it's always important to follow your manufacturer's instructions for use. Absolutely. So how do we remove TDS from the water? There's certainly one option, and many practices do this. You can always send a staff member to the store 3 or 4 times a week to buy as many jugs of distilled water as he or she can carry to the car and find a place to store in the office. But many practices prefer to have some on-site method for water purification.
Well, allowing the staff members to do what they're educated to do for patient care rather than going shopping.
Yeah, that's right. That's right. If you don't have to spend time at the store, you can spend more time with patients. So there are 3 primary methods of removing total dissolved solids from water. And I'm just going to touch on those very briefly. One technology is commonly referred to as reverse osmosis. Another is referred to as deionization. And then there's also distillation, which is, of course, is what produces distilled water. So I'm going to touch on each of those very briefly. Reverse osmosis, it can be a little confusing, so I'll describe this at just a high level, but basically this is a form of physical filtration, but it happens at an almost molecular level. There's a membrane that allows mostly only water to pass through. The dissolved solids that aren't able to pass through that membrane will be washed away and will actually be washed to the drain. That's what is commonly referred to in this context as brine. Think about it as separating the water into good water and bad water. The processed water that you want that has nearly all of the dissolved solids removed from it, and then all of the dissolved solids that were removed get flushed to the drain. So depending upon the type of system that you have, what your water pressure is, the specific type of membrane that is in place, reverse osmosis typically will remove anywhere from 90% up to 98% of the total dissolved solids from water. And as I mentioned, not all reverse osmosis systems and membranes are created equal. So a small, relatively inexpensive RO system that may be installed in a home, just for drinking water, is going to be of a very different capacity, different efficiency than what would be a more sort of commercial grade, higher capacity reverse osmosis system. Deionization is another technology to remove dissolved solids from water. This works very differently in that deionization filters are filled with a special type of resin. And what this resin does is, again, similar to softening in some sense in that it's working at an ionic level. So this creates what's known as an electrochemical reaction that's actually just removing the ions from the water. So it's not exchanging one type of ion for another, it's just removing ions from the water, and that's why it's called deionization. So this technology is capable of producing an extremely high purity water all the way down to 0 TDS.
Ideal.
That's what it's
for dairy centers.
Yeah, certainly ideal for what you would want to use inside a steam sterilizer. That's right. So DI filters, unlike a water softening system, aren't regenerated. When a DI filter is expired, it's kind of loaded with those minerals that it has removed and just needs to be replaced at some point. Now, how often do you need to replace these filters?
Depends.
It depends. That's right. It depends on how how high the level of dissolved solids would be in the water that is passing through these deionization filters. For this reason, deionization filters are frequently preceded by some type of reverse osmosis membrane, because reverse osmosis is kind of the workhorse of a system like this, like the one that's depicted on the right-hand side of your screen here. This is just an example of a water purifying system that involves pre-filtration of some of those.
Like the coffee filter.
That's right, but at a much finer level. It's removing some of those suspended solids, also removing chlorine as a first step to protect the reverse osmosis membrane. In this case, that RO membrane is doing really the lion's share of the work. It's going to remove 95% or more of the dissolved solids. And then the deionization filter or filters are really only used for removing that last little bit of dissolved solids from the water when you need to get it all the way down to zero, for instance, for use in a steam sterilizer. If a system only had deionization filters, Leanne, you'd have to replace those filters a lot more often.
Right.
Yeah, so it's actually kind of a national average for dissolved solids in city water is somewhere around 300 parts per million. So if you have an RO filter ahead of the deionization filters, quick mental math here, if you're removing about 95% of that dissolved solids, you'd still have about 15 part per million left that the deionization filters would then remove for use during steam sterilization. Because 15 parts per million water is not good enough for use in a steam sterilizer. The Statim, for instance, would tell you you've got poor water quality if you tried to use 15 part per million water inside its reservoir. Okay, distillation. The picture on this slide is an example of a very common type of tabletop distiller. Some dental practices use a machine like this. Distillation is a simple process. It just heats water to its boiling point to turn it to steam. The contaminants that were the dissolved solids in the water are left behind, and then that water recondenses, and theoretically, as that vapor cools and returns to its liquid state, you have water that has zero dissolved solids remaining, and ideally and typically a neutral pH. So pH is a measure of the acidity or alkalinity of water. It's a scale. Perfectly neutral pH water is 7, and that's what you would want ideally. However, the downside to on-site distilling can be, well, several factors. It's slow.
It's hot.
It's very hot. Can be noisy depending on the system you have, and really uses a lot of energy as well. So while some practices have a system like this, I wouldn't say it's the ideal way to produce zero TDS water when you have the ability to produce that via a combination of reverse osmosis and deionization. Those are technologies that can get you to the same, essentially the same endpoint that you want, which is zero TDS water, can just do it in a more efficient way.
And Matt, before we move on to this next part, again, just to clarify, you know, when an office chooses to improve the quality of the water, the incoming water, and they're looking at things like pre-filtration, reverse osmosis, deionization, distilling, that still is not treating the water for the dental unit. That's another step that goes on as it occurs there. But I've heard offices or questions at programs when people say, oh, I don't have to worry about my water lines because I use distilled water. That's not treating their water lines.
That is an important point, Leanne. That is a common misconception. The contamination issues that are associated with dental unit water lines are, in a sense, almost endemic to the design of those types of systems and how the water is used. It's a very slow flow rate, very small tubes. You've got stagnation. You've got water that warms to room temperature or sometimes higher if a practice is using water line heaters, which we would always caution against, by the way. So you're absolutely right. Simply using distilled water is not a treatment protocol for dental unit water lines. And that's because you could actually put completely sterile water into a standard dental delivery system, and very quickly you would have to contend with contamination issues. So back to steam sterilization here for just a moment. Again, ideally these systems would use zero TDS water. You might see this referred to as a distilled quality. I put that in quotes on this slide because it doesn't have to be distilled water. You could use deionized water as long as it's at that 0 TDS level. And as I mentioned earlier, in the vast majority of cases, just using reverse osmosis system or reverse osmosis grade water would not be pure enough for steam sterilizers. The other thing I want to do here very briefly is just distinguish between sterilizers that use fresh water for each cycle and sterilizers that actually recycle water. There's a bit of a trade-off there. Sterilizers that use fresh water for each cycle obviously their reservoirs need to be filled more frequently. Whereas the sterilizers that recirculate water, there is a trade-off there. It can be more efficient in some sense because the dental staff isn't having to fill that reservoir as often. But typically what you find is that the maintenance protocols associated with the sterilizers that recirculate water can be a little bit more involved. You might need to drain that reservoir and refill it on at least a weekly basis. Typically you'd have to run a special cleaner through that system, typically on at least a monthly basis. And that's just a little bit of the trade-off involved there between those two types of steam sterilizers. The other thing that I want to draw our attention to, this is kind of getting back to the water out part of this presentation, and this is specific to sterilizers that use fresh water for each cycle. They need to then discharge wastewater.
It's got to go somewhere.
It's got to go somewhere. That's right. And so typically what you see is what's commonly referred to as a condenser bottle. Yep. And it's basically just like a bottle that collects the wastewater after each sterilization cycle.
It's usually in a cabinet, right?
It's usually just sitting in a cabinet. That's right, underneath the sterilizer. And it basically just collects this water as a holding tank before it needs to be emptied manually by the dental staff. Because that exhaust is very, very hot. It is too hot to go directly down the drain. 207
degrees Fahrenheit. I mean, if you think about it, it takes a while for that to cool down.
It does. It takes a while for it to cool down, and that is so hot that most drainway systems now in most parts of the country are plastic. So it could be PVC or ABS plastic, but in either case, if you're continually putting water that's that hot down the drain, you can actually melt that plumbing. So that's why those condenser bottles that are included with these types of systems collect that wastewater. And the thing that can be inconvenient about that for the staff is now that is a process that needs to be monitored.
To know if when it's full and when it needs to be empty.
That's right.
You're going to have a flood
otherwise. We don't want that thing to overflow. And so, practices will get into the learned behavior of having to monitor that condenser bottle throughout the day, and when it's getting too full, got to unthread the cap that's usually on the top of that thing, lift it out manually from usually a lower base cabinet, carry it over the sink, dump it down the drain, put it back and reverse the process, put everything back together. So that's certainly inconvenient. It's not exactly ergonomic either. The other thing that we really, should think about and be concerned about is that even those condenser bottles can actually vent steam inside the cabinet. And sometimes even, being as careful as possible, you can just spill the water, from a full condenser bottle as you're trying to remove it to take it to the sink to dump it out. And the problems with that are that you're actually, between spills and between steam inside a closed cabinet, you're creating a humid environment.
And we know what bacteria and mold like.
Yeah, that's
warm,
right.
Dark, and moist.
I've seen pictures from practices who had complained about what's going on the inside of my cabinets. They might see mildew starting to form or even rust starting to form inside their cabinets. It's might be the result of the steam that escapes from that condenser bottle or spills inside the cabinet. So that can create damage over time as well. I'm going to show you my cursor here on this screen now. The picture on the right is a system that can actually cool that wastewater that's discharged from the sterilizer and actually send it directly down the drain. And the way that works,
carefully at the right temperature.
Well, that's right. What this system in particular is designed to do is to cool down that exhaust wastewater from the sterilizer.
Not just let it cool, but to actually actively cool it.
To actively cool it. So what you don't see in this tank, and this actually importantly, Leanne, would actually replace the condenser bottle. The condenser bottle would no longer be used with a system like this, because if you see my cursor here, what happens is you would have a high temperature rated tubing from your sterilizer that would plug right here into the top of this manifold. What you don't see here is that there is a copper coil that extends almost all the way to the bottom of this tank and back up and out into the drain. This tank is always full of cold water from the city.
So the coil is submerged in cold water.
Yeah, think about it as being in a cold bath.
Okay.
And so the copper coil is really great at transferring that thermal energy. So it's surrounded by this cold water, so it is going to cool down that sterilizer discharge pretty dramatically, so it is able to be sent directly down the drain safely. So when a system like what's depicted here is installed, and once it's installed properly, there's no more user maintenance involved. There's no more monitoring this tank. It's going to cool down that wastewater automatically and send it directly to the drain. The other thing that's unique about a system like this is that after multiple cycles, back to back to back, of course, that coolant water is going to warm up.
Right, especially if they're using multiple sterilizers, Matt.
That's right. And some systems can actually accept that wastewater from more than one sterilizer. But as that coolant warms up, it's no longer as effective as it could be as a coolant. So this system will actually accept cold water from the city, and it has a thermal regulator built into it. It's kind of like a thermostat in that sense. Mm-hmm. It will open a valve when it senses that the coolant water is now too warm to be effective. And as it opens that valve, fresh cold water comes in from the city supply, and because it's under pressure, by displacement, it will push that warm coolant water out to the drain.
So it's like a homeostatic environment.
Yeah, you know, the temperature will fluctuate a little bit, but whenever it senses that that coolant water is too warm, it lets fresh cold water in, and we're back down to a much cooler temperature in the system.
So this never has to be emptied or anything that's connected to the plumbing?
That's right.
Okay.
That's right. So this is helping to protect drains and cabinets, importantly, as we talked about earlier.
And staff.
But also staff time. Yeah, this is a huge time saver for the staff if they no longer have to monitor the condenser bottle. Okay, quickly I want to talk about instrument washers. More and more practices are moving to instrument washers as a step prior to sterilization, and instrument washers are great for lots of reasons. However, we need to be concerned about the quality of water that's going into that instrument washer. That's because certain types of contaminants in the water, again, I'm not speaking about microbiological contamination, but just other factors that might even come in your city water supply, dissolved solids, chlorides, iron, etc. Inside an instrument washer, you can actually create a very aggressive environment because it's being combined with oxygen, high heat. These are catalysts for chemical reactions. In particular, a chemical reaction called oxidation. And oxidation, that process, is what can actually begin to discolor dental instruments, can begin to create spotting, and even pitting and corrosion of those.
So like the brown pitting and staining that we're seeing can actually be a result of poor quality water that's being used.
Very often the instrument washer might get blamed for that, even though it's not the instrument washer's fault. It's the result of a poor water quality that's being used there. So something that the practice can do in many cases, if an instrument washer has a port that will accept a higher purity water, specifically just for its final rinse cycle, that can be greatly beneficial in protecting those dental instruments from that type of spotting and corrosion and discoloration over time. The analogy that I like to use here is that of driving your car into a car wash bay. You've seen that there's usually a little box on the wall with a
choose
selector.
What you want, yes.
You know, choose, are we rinse, are we a soap cycle, are we, you know, the foaming brush, all this kind of stuff. But you'll almost always see that there is an option for what's usually referred to as a spot-free final rinse.
Yes.
So if you do that at the very end, you've probably noticed on your car, Leanne, that you won't get those water spots.
The white spots.
As your car drives. Yeah, that's right. It's the same dynamic at play here, where if you use a high purity water, meaning a low TDS water, you're rinsing away those minerals that would otherwise be left on the instruments to dry and create that spotting.
And Matt, I would think also if you're using it for a limited part of the procedure, the service, you don't have to use as much of the treated water. So that's an advantage from that point too.
That's a really good point, Leanne. It's very rarely necessary to treat all of the water for the entire cycle in an instrument washer. You know, most washers will use 10 gallons or so of water for the entire cycle, whereas the final rinse cycle might only be about 2 gallons. And you can really get your bang for your buck by just treating that last 2 gallons or so in the final rinse cycle. Okay, dental delivery systems. I told you we're not going to spend a lot of time on this, but water in, water out. Let's talk about the water that we're feeding to our dental delivery system, whether it's in a dental bottle or from a directly connected municipal source. Ideally, we would want water that is relatively low hardness. We don't want to use really, really hard water if we can avoid it in a delivery system because of that buildup of scale that I talked about before that can eventually clog valves inside a delivery system. And we also want water that is going to be a neutral pH. We don't want to use water that's very acidic or too alkaline. Those can create different types of problems.
And also the scale that's there has the potential as being used as a nutritive source for the bacteria that are there. So it can also cause another issue as well.
Yeah, you know about that even better than I do, Leanne. You're right. So as you mentioned earlier, even using a good quality input water is not going to be sufficient to think about as in terms of waterline treatment, because as I'm sure most of the people on this webinar understand, there are standards for a maximum level of microbiological contamination. These are essentially come straight from that EPA standard for public drinking water that I referenced earlier, been adopted by the CDC, harmonized in the ADA as well. We need that microbiological contamination to be under 500, what's referred to as CFUs or colony forming units of this bacteria per milliliter. So, and as I mentioned earlier, again, it's almost endemic to the nature of this type of system. It's a very complex system. There's lots of factors involved. So the use of waterline cleaners and antimicrobial agents is absolutely a necessary parts of proper waterline care. Just a plug for some of those continuing education resources where I know you've done a much deeper dive on this. If you've not viewed or listened to some of these resources, I highly recommend it. Now, regardless of what the practice is doing in terms of the products that they may be using for waterline maintenance, there's some basic protocols that everyone should be following no matter what. Discharging air and water lines for at least 20 to 30 seconds after each patient.
And that's every air and water line, not just the main one that was used. They all have to be.
This is a long established protocol. This originally came, I believe, from a 2003 CDC set of recommendations. So that's something that should be done after every single patient. I mentioned this earlier, but we really should not be using waterline heaters. Waterline heaters can actually, basically what you're doing is forming an incubator that can exacerbate microbiological growth in the water lines. So we strongly recommend not using waterline heaters.
Anytime you get above 77 degrees, Matt, the waterborne bacteria have hit their sweet spot. And unfortunately, while we want to be kind to our patients, that 98.6 water is just going to grow bacteria at extremely high rates.
That's right. Finally, again, this is well established by the CDC and other best practice type recommendations, but for surgical procedures, we should never use water from a standard dental delivery unit. For surgical procedures, we have to be using sterile water delivered by sterile means. So whether that's sterile water or saline delivered by autoclavable or disposable bulb syringes, tubing, etc.
Closed hand pieces. And when we say surgical, Matt, we're talking about when there's an exposure to the pulp, to the circulatory system. So it can be things like endodontic treatment, biopsy, periodontal surgery. So it's beyond oral surgery, quote unquote.
That's right. Finally, it's important, and this is really just kind of a best practice recommendation here, we should be monitoring the microbiological quality of the treatment water, following the instructions for use from the product that you're using for maintenance, from the dental unit manufacturer, etc. People ask me this, my answer is always you should be monitoring this at least on a quarterly basis, if not more frequently than that, but follow those IFUs.
And remember that when you're looking at, as you said, Matt, the dental unit itself, as well as the product that's being used, if there's a specific recommendation for monitoring frequency, you need to go with the shortest one to be in compliance.
That's right. Okay. Plumbing regulations. I know this is the slide that everyone's been really excited for. Everybody gets excited to talk about plumbing regulations, but it is actually very important, because the last thing you want is a piece of equipment that's red tagged, you know, right before you're ready to start using it because a local code wasn't followed to the letter. So plumbing requirements can vary. There are state level plumbing requirements, there are national level plumbing requirements, but even at a local level, sometimes a municipality is looking for different requirements. So what I'll say about this is it's always important to consult a licensed professional who understands those local codes and is able to ensure that you're following any applicable local codes from a plumbing standpoint. Now, one of those things that you'll hear a lot about if you talk to a plumbing inspector is this issue of backflow prevention. So I know to many of us who are entrenched in dentistry, we think about backflow prevention as one thing in the operatory environment. But what I'm talking about now is actually a backflow prevention that protects the public water supply. So what you might see in a utility room, a mechanical room, you might see special types of backflow preventers that will keep any possible contamination from either the sterilization room or the operatory environment from coming backwards and potentially contaminating the public water supply. So this is a big one that plumbing inspectors will be looking for, and based on where you are, they may have different requirements. You might need to have some form of backflow prevention installed only on your main water line. In some areas, especially for the practices that would like to connect their delivery systems directly to a municipal source.
Like if they're doing something underneath the chair and they're putting some sort of a cartridge or a tube to treat their water line.
Yeah.
That would be the issue.
Yeah, and maybe maybe a practice just does not want to fill dental bottles. They want to connect their delivery system directly to the city water. That's where many plumbing inspectors will get real nervous about that and say, you might even need a specialty type of backflow preventer that's often called an RPZ, which stands for a reduced pressure zone valve. This is a special type of backflow preventer that might even be required to be installed on every single line to each operatory. That, it can get the job done from a backflow prevention standpoint, but it can be problematic for the practice because these devices can be expensive to install initially, but very frequently they also have to be inspected and recertified on an annual basis. So there's an ongoing cost associated with that. And these RPZs can actually also leak. They can even introduce contamination, which is the last thing that you want when you're delivering water to your dental delivery systems. So all of these plumbing products are tested and certified to specific plumbing standards, and they're typically tested by third-party entities and laboratories and might carry some sort of mark associated with them. I've put a couple of marks in the lower corner here. This, you might be familiar with the CSA mark, that's the Canadian standards, also the UPC mark, that is from IAPMO, which is another third-party certification entity. What they're typically testing these plumbing products to the same standards. They just have different certification seals because they're different entities. So, CSA in particular is one that has a mark that even says, it clarifies this meets UPC as well, so they're testing to the same standards.
Now, Matt, when you've talked about new construction and things like this, but what if somebody's going to be going through a remodel in their office? Would this be a piece of equipment that they might want to consider while they're already opening up into the walls or into the floor? And to avoid the single
RPZs. Yeah, that's a perfect time, especially if you're building a new office or you're maybe evaluating a major remodel where you might be opening up a floor or a wall and running additional plumbing. A system like that, which is depicted here on the right hand side, just as an example, can serve a number of objectives and have a number of benefits. This system in particular will filter that inbound water to a very fine level, so it's removing some of those suspended solids, that particulate that might still come from the city, down to a very, very fine level, down to like 1 micron, in width. So extremely fine level of physical filtration. But then also a system like this has built-in backflow prevention.
So it covers the whole office.
Yeah, it covers the entire operatory environment. So typically you wouldn't be running, water through a system like this to the kitchen or the break room. But yes, this system in particular, just as an example, is designed to filter that water from the city, send it to each operatory for those connected systems. We'll also have built-in backflow prevention. In this case, this is CSA certified backflow prevention. And you also want to make sure that you have a way to introduce periodic shock treatments to your water lines. If you have a directly connected municipal source, it can be difficult sometimes to know how to introduce a shock treatment when that may be necessary. So a system like this will give you a centralized means of introducing a shock treatment to the water lines that are connected to the system. Okay. Great segue into this one of these last slides here, Leanne. Other things to consider if you're building a new office or undergoing a remodeling project. Obviously, you want to work with the best team possible. You want to work with designers and equipment specialists that understand some of these systems and that have experience with solutions that can meet your clinical objectives. You want to also think about water first, not last. So think about water as being as crucial to dentistry as your air and vacuum systems. Because as I hope we've established in this presentation, water is absolutely critical to a number of practices, workflows, and needs within the building. I recommended installing a sediment filter on your main inbound water line. That's a simple and inexpensive way to catch some of that junk that can still be introduced even between the municipal water plant and the practice. We talked a little bit about instrument washers. I think this is especially important if you're considering purchasing and installing an instrument washer, that you get a very basic water test that would give you a profile of the water that's coming from the city. So we're looking for contaminants here that could potentially cause problems inside the instrument washer because of that combination of heat and oxygen that I described. Not necessarily microbiological contamination, but for some of those other factors, dissolved solids, chlorides, iron, etc. Sometimes you can get reports like this from the city, but also from a purveyor of local water treatment equipment, a basic water chemistry profile that would be available from a laboratory. I would just recommend working with your rep, work with your equipment specialist who's familiar with these types of tests, who might be actually recommending and selling that instrument washer. Getting that water test is really important. Finally, think about how you might be able to future-proof your project in simple ways, by running conduit for future expansion, or by running a second drain waste line, into your sterilization room. I've seen more and more that when you've got everything opened up anyway, there are a lot of benefits to just running a second drain waste line with its own little trap in it, just like you'd see under your sink, but go ahead and run that right into the base of your Steri tower. That way you can collect all those drain connections in one spot right underneath your sterilizers and not have to mix everything into the same drain waste line that's connected to your sink. Finally, I would say, just purely from an efficiency and over time a cost saving standpoint, really consider systems that are designed to purify water on site, and also systems that are designed to manage that wastewater that comes from steam sterilizer, because this is going to save your staff in particular a lot of time and headaches involved with just managing some of these things, going out and purchasing water from the store. For instance, when you factor in your staff time and your costs associated with that, this becomes an extremely expensive proposition to buy a bunch of, jugs of distilled water at the corner grocery store multiple times throughout the week. So think about some of these systems that are available to purify, filter water on site, and to manage this wastewater as it leaves the practice. The last little plug here that I will give the group that's in attendance here as what might be a helpful resource is a book that's called The Book on Dental Water. This will really address all of the topics that we've discussed here today, and actually many more as it relates to the use of water in the practice. And it does so at really a very high level in layperson's terms. It's not overly technical, but this is a resource that you can download for free as a PDF or as an ebook if you want to use it with your e-reader. You can link to that from crosstextlearning.com. And then finally, I know we want to get into a brief Q&A portion here at the end of our time together today. But anyone with questions after our Q&A portion tonight can, feel free to shoot me an email. You can reach me at mchandler@crosstext.com. So with that, I just again want to thank you for your attention here today, and want to turn this over for questions and answers.
Matt, thank you so much. I think now we have the told story about dental unit water and water quality coming into our practice, that we can now put together the entire process of how we work with water. And Matt's right now going to be reviewing some of the questions that are here. And we do have Jim Chandler, who's joined us for this portion. And Jim is the author, as I said, of the book on dental water. And when you go to crosstextlearning.com, you'll find a hyperlink that you can click on, and you'd be able to download that resource. But at this point, Matt, can you share some of the questions that are coming up tonight?
Yeah, sure. It looks like we've had some good questions come in. Since we just spoke about plumbing regulations most recently, and that's a topic many of us aren't too familiar with, I see a question here that is about those plumbing regulations, asking, are these new regulations, or are these simply best practice recommendations for things like backflow prevention? I'm assuming that this person is asking about. Jim, is that something that you'd want to address in terms of some of these plumbing regulations that are in place?
Sure, Matt. Glad to be here to answer some of your questions. Plumbing codes are changing all the time, and backflow prevention is one of the largest growing segments of plumbing concerns throughout the United States and worldwide. Air gaps, of course, are the most effective way for air gaps. So you can't backflow through an air gap, a certified air gap, that is. But then sometimes you have to repressurize water. So inline, check valve, dual check valve, double checks, RPZs, as Matt said later or earlier. But you have to check with your local plumbing codes. And any designer that you're working with a new facility, or your equipment people, make sure before you run on in to do something that is going to later be inspected, that you run it by your local plumbing code people to make sure that you get their blessing.
Great, Jim, thank you. Matt, is there another question?
Yeah, one question just came in here. One of the things that we talked about earlier was the Safe Drinking Water Act and some of those primary contaminants that have possible health-related concerns associated with them. I gave an example of lead as a contaminant that can have health-related concerns. We had a question that just came in about Flint, Michigan. That was obviously in the news big time several years ago. What do we know about, let's just use Flint, Michigan as an example. Were there issues specific to dental practices in that area because of some of the lead contamination that was discovered? How would you relate that to concerns for a dental practice?
Well, the overriding concern, of course, with something like lead, arsenic, and those kinds of things are basically going to be human health. Water is not consumed in a dental office. Those are not the kinds of contaminants that are going to generally be of concern for dental process water. What they're concerned about, of course, is people drinking tap water, with especially young children in developmental stages, for lead contamination in the body. The one good thing is that if you're going to be using some of the things that you and Leanne described, Matt, like your hyperfiltration followed by deionization, you've eliminated those kinds of contaminants, basically. Again, that's not what they're designed to do necessarily. There's no claims through that, but that's exactly what the hyperfiltration and deionization will do. We'll take out to upwards of 99.5% of those kinds of things. So that's not a big issue in dental practices, but really a human health concern.
Great, thank you. Another question that came in is about just kind of a general checklist. The question was, is there a general checklist available to help make sure our office is following all of these great protocols as it relates to best practices for water? there certainly are some great resources available. You know, I mentioned some of the continuing education resources that are available at crosstextlearning.com. I would also reference specifically as it relates to dental unit water lines at our website, vistaresearchgroup.com. There's also a shortcut link to our support website, which is vrg.support. There's some product-specific resources there, but for sections that are specific to a couple of our different filtration products, VistaPure and VistaClear, you can navigate to a section that gives you some resources not only for installation and maintenance and that sort of thing, but some best practices as it relates to dental unit waterline protocols. It will summarize some of those things that I talked about related to flushing the water lines for 20 to 30 seconds, you know, after each patient, not using waterline heaters. Making sure that for surgical procedures, you're only using sterile water delivered by sterile means, etc. So some of those types of checklist type items are available there. And again, I would just say using some type of antimicrobial product in your water lines is critical, and you just want to be sure that you're following the manufacturer's instructions for use.
And always, Matt, we want to refer people back to the CDC guidelines, and I would encourage you to look at the 2016 summary document as far as the checklists that are in the back, Matt. There's an administrative checklist, and there's also an observational checklist, and these are great ways to make sure that your practice is in basic compliance with best recommended practice. We have time for one more question, Matt.
Let's see, I'm going through the list here. Looks like we have addressed most of the questions we received. If there are any last questions, feel free to just enter those into the chat box there.
And as Matt sort of reviews that, I would also encourage you to take time to do the follow-up quiz after tonight's webinar that you can then get your CE credits issued after you've taken that exam.
Any other last thoughts, Jim, as we talk about
wisdom, Jim?
The general use of water in dentistry, water coming in, water going out?
Well, times have changed. The way dentistry was done 40 and 50 years ago has certainly been updated. The use of independent bottles, the use of filtration. You have to use high quality water for all kinds of things in the dental offices. Matt and Leanne covered. You know, the sterilization center is a very complex environment. And so having high quality water there to protect instruments while they're in their processing state to help minimize interface with hot bottles and things like that, with automatic waste devices like for your autoclaves. And just pay attention, set up a protocol, follow it, test regularly, make sure the protocols are being followed, and update them occasionally. Look to, as Leanne says, the CDC and other resources, American Dental Association, any other places that you can glean information to help make your office a better environment.
Great. Thanks so much, Jim. Thank you, Leanne. Thank you, everyone, for your time today. That's a great place to end, and we are just over. So again, just want to thank you for your time. We're going to wrap up. Thanks so much.